I want you to imagine walking into a completely new room. Maybe it's a coffee shop in a city you've never visited, or, a brand new office building you're stepping into for the very first time.
Right, somewhere you absolutely know you've never been.
Exactly. You cross the threshold, look around at the unfamiliar furniture, the strange lighting, and suddenly you just get hit with it.
Yeah, that eerie feeling.
That unexplainable spine tingle, the feeling of, I've been here before. I mean, for an absolute fact you haven't, but your brain is just screaming that this exact moment has already happened.
It's a deeply weird, intensely human experience.
It really is. But now, I want you to consider something entirely different. Imagine your smartphone feeling that exact same eerie sensation.
Which sounds completely wild.
Right. Or like a self-driving car barreling down the highway, suddenly gripped by the feeling that it has driven this exact stretch of road before, even though its GPS knows it hasn't. I mean, how is that even possible for a machine?
Well, it sounds like a glitch in the matrix when you frame it that way.
Yeah.
We naturally assume that machines, because they rely on binary logic and, deterministic code, are immune to the kind of cognitive hiccups humans experience.
Because they don't have feelings.
Exactly. But if we actually look under the hood at the underlying architecture of modern AI, the structural mismatch that causes human déjà vu has a direct, highly functional counterpart in machine code.
And that is exactly what we are unpacking in today's deep dive. We're looking at a document called AI and Déjà Vu, and our mission today is to explore how this biological brain glitch is now showing up in artificial intelligence.
And more importantly, what that ultimately means for the technology that you rely on every single day.
Right. Because to understand how a server rack or, say, a warehouse robot gets déjà vu, we really need to look at what is happening inside our own heads first, before we cross into the AI stuff.
Yeah, we have to start with the biology. The term itself is French, literally meaning already seen.
Right.
And it's usually just this brief sensation, maybe lasting seconds to a minute, where a totally novel situation feels familiar.
And it's incredibly common.
Especially for younger people. 70 to 80% of teenagers and people in their 20s experience it regularly.
Wait, really? It drops off as you get older?
Yeah, it drops to about 60 to 70% for people in their 30s and 40s, and then down to 40 or 50% for those over 60.
I had no idea it was an age thing. So what is actually happening in the brain? We usually think of memory as a single, perfectly indexed file cabinet.
Which is a massive misunderstanding of human neuroscience. I mean, memory is not a static retrieval process. It's a highly complex, dynamic network of predictions.
Okay.
The prevailing consensus on déjà vu points to a temporary timing mismatch. Your brain basically runs on a dual-speed processing system, two parallel tracks.
Key tracks, got it.
You have a very fast surface-level familiarity check, and then a much slower detailed recollection system.
Okay, let's unpack this. Let me try an analogy. It's basically like having a hyperactive guard dog at your front door, right?
Okay, I like where this is going.
So the dog looks out the window and instantly barks, "I recognize this person." That's your fast system. But the slow system is the dog's owner, who is still fumbling with their glasses, trying to actually see who's at the door.
That is a perfect way to visualize it.
When the dog is right, but the owner sees a stranger, you get that eerie feeling. The fast "I know this" signal hits your conscious mind before the slow "I remember it" signal actually loads.
Right. And a delay of just hundreds of milliseconds between those two systems is enough to create the glitch.
And everyday things can trigger it, right? Like being super tired.
Oh, absolutely. Stress, exhaustion, sudden changes in scenery, mild head bumps, fevers, or even certain medications. Anything that throws off that delicate timing.
So your fast system fires, but your slow system comes up empty, and you're left holding the bag of this weird familiarity.
Exactly. You have the sensation of a memory without any actual memory attached.
Okay, so that makes sense for humans. But let's cross the bridge to AI architecture, because I know computers don't get tired or stressed in the same way.
They don't. But the mapping between biological and artificial architecture here is striking. Modern AI, especially large language models, operates using a very similar fast and slow paradigm.
Okay, so map it out for us. What is the AI equivalent of that fast human feeling?
The human "I know this" feeling translates to what we call a similarity score in AI. It's a quick familiarity check.
Right, because an AI isn't reading text or looking at an image the way we do. It translates everything into numbers.
Exactly. It uses vector embeddings. When you give an AI a prompt, it instantly converts your input into a mathematical vector in this massive, high-dimensional space.
And the FAST system's job is just to measure the distance.
Yes, it just checks the physical distance between your new vector and all the vectors it's seen before. If the new one lands right next to a cluster of past data, the AI generates a very high similarity score.
Like, I don't know what this is, but it looks 99% like my old data.
Exactly. It's incredibly fast. And then you have the slow human recollection, which is the AI's careful database search.
Doing the actual heavy lifting.
Right. Actually querying the database, parsing specific parameters to construct a nuanced, context-aware response.
But wait, I have to push back on this. We are talking about machines that process information at the speed of light. Why do they even need a fast and slow system?
It's a good question.
I mean, why not just search the whole database perfectly every single time? If it's just code, why build in a system that can mismatch?
What's fascinating here is that, just like the human brain, AI uses shortcuts to save energy and time. Artificial intelligence is bound by physical constraints.
Like electricity and server space.
Exactly. Running a full, deep layer retrieval for every single microinteraction is profoundly inefficient. If an AI did a deep query for a basic hello, it would take 5 seconds to generate and cost a fortune in compute power.
Okay, so it's entirely a matter of efficiency. We force the machine to use shortcuts.
We have to. But this dual process architecture is what creates the opening for the machine version of Déjà vu.
Because what happens when that fast similarity check screams, yes, this is super familiar, but the slow, detailed search comes up empty?
The machine gets trapped in the mismatch.
And to really understand what that looks like, we need to talk about how this AI déjà vu plays out in the real world. The source document gives 4 really distinct examples, starting with chatbots.
Yeah, the chatbot scenario is probably the most common one people interact with.
It's the classic lazy shortcut.
Exactly. So imagine a user asks an AI customer service bot a novel, highly specific question, say, about electric car battery insurance.
Okay.
The bot parses the prompt. The vector embedding for words like insurance, policy, and rates triggers that fast familiarity score. It lands really close to a massive cluster of past queries about standard home insurance.
So instead of engaging the slow system to realize that a lithium-ion car battery is completely different from a suburban roof?
Right, it just recycles an old answer. It spits out generic text about home insurance because the wording felt too familiar. It overrides the nuance.
It's like the bot is saying, I've heard this a million times, even though it literally hasn't.
Precisely. And while that's annoying for customer service, it gets much stranger when we look at language models generating essays or writing code.
You mean when they start hallucinating?
Yes, hallucinating.
Yeah.
Sudden, high-confidence statements without any real supporting data.
Wait, so when an AI confidently lies to me, it's just having déjà vu?
In a lot of cases, yes. The combination of words feels so statistically common in its vector space that the model inherently assumes it must be true. The fast check screams correct so loudly that it bypasses the slow check to verify the facts.
Oh, wow. It's the machine equivalent of a false memory.
Exactly.
But those are just text. Things get wild when we give these systems physical bodies, like in the image recognition example.
Oh, the assembly line example. This one is fascinating. Think about a computer vision system scanning products for quality control. Suddenly, a brand new prototype comes down the belt. Something about the lighting or the shape triggers a massive spike in the fast similarity check.
So it falsely recognizes it.
Right. It preemptively flags the item as a known old product and mislabels it, totally cutting off the slower, high-resolution analysis that would have caught the new details.
It's like seeing someone from behind, recognizing their jacket, and shouting your best friend's name across the street.
Only to realize it's a total stranger when they turn around, yes.
But the stakes are even higher with the warehouse robot. Imagine watching a robot stubbornly driving into a new wall because it feels like the hallway is still there.
The logistics center example.
Yeah. I mean, is the robot actually ignoring its own sensors because its gut feeling is too strong?
It literally is. The warehouse layout changes overnight. The robot rolls out, and as it approaches a spot it's driven through 1,000 times, its fast familiarity signal spikes.
Even though its live LiDAR sensors are staring at a solid wall.
Right. The quick "I've been here" signal literally overpowers the updated map. It thinks its live sensors must be glitching because its historical familiarity is so high.
So it just gets stuck in a physical loop.
Bumping into the wall over and over. It's experiencing profound déjà vu.
So what does this all mean? We've got lazy chatbots, hallucinating models, robots bumping into walls. Is this architecture just a dangerous bug?
Well, no, that's the thing. It's a deeply complex double-edged sword. It's not just a flaw, it's a necessary compromise. And sometimes it's a lifesaver.
Okay, sell me on the good side of this.
Take the autonomous car example. You're as a self-driving car on the highway. The fast scene recognition system says, everything is fine, this matches our standard open road data.
But then something happens.
Right, the slow, detailed sensor array detects a microanomaly, maybe a pedestrian in dark clothing standing in a shadow.
So the fast system says safe, but the slow system says anomaly.
Exactly. And that massive mathematical gap between the two checks triggers an early warning sign. The car effectively feels something is off and slams on the brakes.
Wait, so an AI having déjà vu could actually save your life on the highway?
Yes. The friction between the fast and slow systems acts as a built-in emergency stop.
But that same glitch can be incredibly dangerous in other contexts, right? The source document talked about privacy leaks.
Yeah, that is the ugly side of this, and it's what keeps developers up at night.
How does déjà vu cause a privacy leak?
Well, AI models ingest massive amounts of data, right? Some of that is restricted or personal information that is supposed to be firewalled off.
Okay, so say a user types in a prompt.
And let's say the vector embedding of that prompt happens to mathematically align very closely with a restricted data set.
Oh, I see where this is going. The fast familiarity check trips the wire.
Yes, the similarity score spikes.
Yeah.
And because the system prioritizes fast matches to save compute power, it might greenlight the output before the slower security protocols have time to run their permission checks.
Wow. So it inadvertently spits out personal details or passwords to a total stranger online just because the shape of the query felt familiar.
Exactly. The system falsely recognizes the data and bypasses the slow security check.
So an AI having déjà vu can save your life on the highway but leak your private data online.
It really highlights the tension here. The very mechanism that allows an AI to be safe and cautious can also make it confidently incorrect or insecure.
So how are engineers fixing this? How do you play therapist to a confused machine?
You have to separate the checks. Engineers are restructuring how these processes interact, mostly by implementing a novelty gate.
A novelty gate, how does that work?
It requires both the fast similarity score and the detailed retrieval to agree before the AI is allowed to act. If the fast check says, I know this, but the detailed search is weak, it hits a hard gate.
Like, it forces the system to stop.
Exactly. The system is forced to pause and ask the user for clarification. It breaks the behavioral loop.
It's like forcing the AI to admit it's confused. What else are they doing?
They're teaching skepticism.
Teaching a machine to be skeptical.
Yeah, by introducing a penalty for acting on high familiarity alone. During training, they mathematically punish the AI if it trusts its gut without verifying the facts in its deeper database.
So it learns to second-guess itself.
Right. And alongside that, they use diagnostic flags. Every time there's a mismatch between the fast and slow systems, it logs it. So developers can monitor exactly where the AI is getting confused.
I read about one more fix in the document that I thought was wild memory pruning.
Oh yeah, this one is very biological.
Right, because vector databases get bloated. If the AI remembers every single interaction, its memory gets crowded, and everything starts to feel familiar.
Leading to constant false familiarity. So engineers run periodic pruning algorithms. They literally reset parts of the memory.
Do they teach it to forget?
Yes. By intentionally inducing forgetting, just like a human brain letting go of old details, they maintain the clarity of the remaining data.
Honestly, teaching the AI to be skeptical, forcing it to pause and ask questions, letting it naturally forget things so its brain doesn't get cluttered, it sounds like cognitive maturity.
It really does.
Like teaching a teenager to take a deep breath and not just act on impulse.
Well, if we connect this to the bigger picture, that parallel is totally intentional. This isn't just about fixing software bugs anymore. We're building a bridge between cognitive neuroscience and machine intelligence.
We're making AI robust by learning from human brain flaws.
Exactly. We're reverse engineering our own glitches to make artificial systems better.
Which brings us full circle. I mean, we started this journey with that weird fleeting feeling in your own brain when you walk into a new room.
Right.
We discovered it's just a timing mismatch between your fast and slow memory tracks. And then we mapped that exact same glitch onto chatbots, warehouse robots, and self-driving cars.
It's all the same fundamental architecture.
And here's where it gets really interesting. We spend so much time in our culture worrying about AI becoming too smart or too alien.
Yeah, the sci-fi doomsday scenarios.
Exactly. But maybe the real wild card is that AI is starting to inherit our most bizarre human cognitive quirks.
That's a great point.
So I want to leave you with this to ponder as you go about your day. If we are making machines safer and better by studying human brain glitches like déjà vu, what other weird, messy human feelings might we accidentally code into the AI of tomorrow?
That is a phenomenal question to end on.
Thank you so much for joining us on this deep dive. Keep questioning the world around you, keep an eye on the tech you use every day, and we will catch you next time. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.